let's look at exponents and scientific notation, which is section 1.7 in your textbook. But wherever your teacher puts this video, okay. I prefer it to be before lines and exponentials. I kind of like reviewing this before doing some exponential work. But anyway, up to your teacher. They're in charge. So we will represent values using exponents, perform operations on numbers and number expressions with exponents, use properties of the real number system, represent and convert values between decimals and scientific notation, interpret values involving exponents, decimals, or scientific notation in that situation that's given. So really our focus will be on exponents because they're not the easiest, can to open and devour. So let's look at example 1 called bacteria, but they are very useful. So let's see how they're useful. It says this table keeps track of the number of bacteria after minutes pass. Okay, so no minutes have passed. So that's at the beginning, I guess, of when we're keeping track of time. 1 minute passed, 2, 3, 4, 5 minutes passed. Okay, I don't like having an extra sheet. And it looks like in the beginning, or no minutes have passed, there were 4. And then after 1 minute, now there are 12. And now, okay, so they're growing. There's more bacteria and more every minute that passes. Then 36, then 108 after 3 minutes. Okay. What is the pattern of their growth? Okay, so take a moment and try to figure out what is happening at each step of this as a pattern. Are they adding the same amount? What's happening? So without me saying it, you should try to figure that out. If you saw it right off the bat, cool. I sometimes don't. But I do know that if I'm adding, it would be 4 plus 8 to get 12. And then 8 plus 12 does not make 36. If I multiply by 3, I get 12. What's 12 times 3? Is that 36? Here we go. We pull out our 3 times 12. 36. Okay, so here's what I see. So I see 4 times 3 makes 12. 12 times 3 makes 36. 36 times 3 makes 108. Okay, so it looks like every step of the way it is tripling. All right, so from here to here, times by 3. From here to here, times by 3. From here to here, times by 3. Okay, so what is the pattern of their growth? It started with 4 bacteria and triples for every minute that passes. So there's our pattern. Fill in the table where it actually says pattern. Okay, so right here, using your observation. Okay, actually, so now that we know the pattern, I'm going to fill in these and then I'm going to start writing over here. So what would be next? 108 times 3, 324. And then 324 times 3, 972. Okay, 972. All right, and the next one, so it says fill in the table where it says pattern using your observation. Okay, so this is just a straight 4, but this 12 is really 4 times 3. This 36 was 12 times 3, but we wrote 12 as 4 times 3. So this would actually be 4 times 3 and then times 3 again to get to 36. Because that was, so if we did 4 times 3 to get 12, and then 4 times 3 times 3, triple again to get 36. and then triple that. So start with 4 times 3 times 3, 4 times 3 times 3, and then do another times 3 to get 108. Okay, so this would be 4 times 3 times 3 times 3. Uh-oh, I'm running out of space. There's so many times 3s here. This one, so started at 4, but then tripled 1, 2, 3, 4 times. So started with 4, tripled 1, 2, 3, 4 times. Okay. Triple to get 12, triple to get 36, triple to get 108, tripled again in a minute to get 324, and then yet again, 4 times 3 times 3 times 3 times 3 times 3. Squeeze it in there. Okay, so we filled in the table where it says pattern using that observation. So this is what's happening. But now that I look at it like this, okay, so we started noticing this pattern, but then rewriting it like that lets me kind of see. It says now go back and rewrite the number of bacteria using exponents where possible to fill in the last column of the table. So here, okay, how can we use our rules of exponents to rewrite this? Well. Let's see. So this is just 4. Let's maybe write some of these. This is 4 times 3. Okay. This is 4 times 3 squared. So I have an exponent here, 4 times 3 squared. So this would just be to the first power. This would be 4 times 3 times 3 times 3 is 3 cubed. So 4 times 3 to the third power. This would be 1, 2, 3, 4. 4 times 3 to the fourth power. So 3, this 4 got tripled 4 times, and this 4 got tripled 5 times. 4 times 3 to the fifth. That must mean, so we go 5, 4, 3, 2, 1. There was no tripling here. And here's what's interesting about this. This usually makes students uncomfortable. And actually, I mean, it took a long time for the invention of 0 to even happen in India for the first time. But like 0 makes people uncomfortable. But this is multiplying times 3 0 times. And look at what happens when we even punch that into the calculator. 4 tripled 0 times is 4. Because tripling it 0 times did nothing. I mean, you just didn't triple it. So this actually, here's our rewrite. What do we notice? Well, I feel like that is what we notice. We notice that with every minute that passes, let's write this down. The exponent on the 3 increases. Yeah. So I notice that if we're tripling, if the pattern is to multiply by 3 every time, really there's a little pattern happening with the exponents. They match how many minutes have passed, right? So it got tripled 5 times because 5 minutes have passed. So that is what I notice about those exponents. Let's look at example 2, where we're looking at the milligrams of ibuprofen. Okay. This table keeps track of milligrams of ibuprofen in the bloodstream after hours have passed. Okay, so what is the pattern of, I guess this is, I should change this language. What is the pattern of, it's not really growing, I see. I mean, after an hour has passed, it's actually going away. Okay, what is the pattern of, it's not growth, decay? What is the pattern of the ibuprofen in the bloodstream decaying or being eliminated. What is the pattern of the ibuprofen being eliminated, aka decaying. Okay, little whatever. What is the pattern? So I want you to take a moment and see what you think this pattern is. Some of it went away, 4 milligrams, but then different amount went away after another hour, 2 milligrams. But I noticed that 4 is half as much as 8, and 2 is half as much as 4. So when I think about this pattern, my mind does this, because I just thought in terms of halves. So take half of 8 to get 4, take half of 4 to get 2. But I will say that if you are a person who saw this other pattern, which is divide by 2, I think that that is wonderful as well. 8 divided by 2 makes 4. 4 divided by 2 makes 2. And then we could continue that as well. But I would also like to mention that these are the same. Splitting in half and portioning into half splits, that's potato here. So let's see what is the pattern. And if I continue this pattern, or you too, please, you as well. Let's see, what would we get here? I feel like I want to continue the pattern. Half of 2 is 1 milligram of ibuprofen in the bloodstream after 3 hours. Half of 1 is a half of milligram in the bloodstream after 4 hours. Oh, what's half of a half? If I take a half and I cut it into 2 equal pieces, that is now 4 pieces. That's a quarter. Yeah, $0.50. It's actually a half milligram and a quarter milligram. But in terms, sometimes I like to use money to remind myself. Also, if we go like this, okay, so multiply by a half. So 1 times, and we get a half. I have students who often show me that there is a way. I'm trying to remember now, like there's a fraction way to do this. So if I do 1/2 and then times, okay, fraction, I think that they found a shortcut for this even, but anyway, 1/2 times 1/2. You don't necessarily have to use math frac to do this. So what I mean is math and then go over to fractions, over to fractions and then do numerator, denominator, or whatever. By the way, to get that, you would hit enter and then that thing would show up. You could just do 0.5 times 0.5, or even here, I'm going to enter it. It says a quarter. It answered in fractions, so that's cool. If I did something like 1/2 divided by 1/2 using parentheses. Oh yeah. Oh wait, why did I divide? I should have multiplied. 1/2 times 1/2, 0.25. So if you put it in like this, it's going to spit out a fraction. And if you put it in like this, it's going to spit out the decimal representation of that fraction, which is fine. But anyway, so, okay. After 5 hours, 1/4 of a milligram is still left in the bloodstream. So what is the pattern of the ibuprofen being eliminated or decaying? The pattern, I would say, is it started with 8 milligrams of ibuprofen in the bloodstream, and for each and half, how about like and half of those milligrams remain after each hour passes. So there is the pattern. Fill in the table using your pattern and exponents wherever possible. Okay, so I'm going to kind of try to follow the thing that we did on the other one, where at the tippity top, we start with 8. Okay, here we go. So we started with 8, and then we did 8 times 1/2, and then we did, that was 4, and then 2 was taking half of that, so that's 8 times 1/2, that's 4, times another half, so take a half, take another half of that, do it again, so that was 2, started with 8, took a half, took another half, took another half to get to 1. Started with 8, took a half, took a half, took a half, and now we're here at 1. And then to get a half, we did it again. So 8 times 1/2 times 1/2 times 1/2 times 1/2. Half of that, and then we would do it again. Yeah, I don't have enough room to squeeze it in there. So let's go ahead and fill in this with the exponents. So here, we started with 8 and we took half of that. I'm going to put this in parentheses now just to make it really clear. No times. We didn't take any halves of 8. But then we took 1/2 of 8. And after 2 hours passed, a half times a half is a half squared. We took a half twice. So we took a half and then we took another half. And then we did it again after 3 hours have passed. So we started with 8, and every hour it was halved, and 3 hours have passed. So half, half, half. And then again, I see the pattern 0, 1, 2, 3, 4 hours pass, and another half is taken. So I can rewrite this as 1/2, 1/2, 1/2, 1/2, 1, 2, 3, 4. 1/2 to the 4th power, and I predict that this will be 1/2 to the 5th power because it will be started at 8 and we did 1, 2, 3, 4, 5, taking a half of it 5 times. Okay, cool. Yeah, I see it. Those exponents are kind of handy so that we don't have to keep writing this out with all of that. I even ran out of space. Predict how many milligrams of ibuprofen will be in the bloodstream after 24 hours. Oh, so if we keep taking a half and we had to take half 5 times for 5 hours, then for 24 hours, I'm thinking 8 times 1/2 to the 24th power. Predict how many milligrams of ibuprofen will be in the bloodstream. Oh, that is a calculator problem if I ever did see one. So here we go. 8. And then you can put in at times. You don't have to. It assumes it if you do this. 1/2. And then to the 24th. Okay, whoa. Hold on. Let me clear this and redo. Oh, whatever. 8. And then I did... let me zoom out so that all the buttons are showing. Clear it. I did 8 and then parentheses 1 divided by 2 to get my half, and then another parenthesis right here. And then this button right here allows you to get into the exponent. Excuse me. And then the exponent was 24. Okay. Boop. Hit enter. And what is that? What is that? Okay. Huh. So I don't know what this means, but I'm going to write it down. Well, I do know what it means, but I don't want to tell you what it means yet because what is that? So let's see, 4.77-ish. Oopsie. And then there's an E and a -7. It looks like that. Yow. I don't know what that, I mean, we'll have to figure that out, I guess. So let's put like, yeah, we'll come back to that to see what's going on there. But a couple of remarks before we move on to thinking about that. First remark. So repeated addition, even though we didn't do any of that here. So repeated addition, just as a reminder from order of operations, repeated addition is represented using what, multiplication? For example, right? 4 plus 4 plus 4 is equal to, some teachers or some people say this is 3 groups of 4 added, or some people write it like this. This is 4 added 3 times, whatever. This is 3 groups of 4 added together, or 4 added 3 times. Okay. So we can use, so multiplication is repeated addition, as seen before. What about repeated subtraction? So repeated subtraction is represented also using multiplication. When I say repeated subtraction, I think I'm implying and repeated addition of the same value. So repeated subtraction of the same value is represented using multiplication too. For example, -4 minus 4 minus 4. So notice how these are all the same amount. And so is the 4 plus 4 plus 4. So these are all negative, and debts are declining. What is this? This would be 3 groups of -4. Or you could restate this as -4 being added 3 times. Because really we could rewrite this as -4 plus a -4, because it's a debt or a takeaway, plus another debt or another negative takeaway. Okay, so repeated addition and repeated subtraction are represented using multiplication, but that is not what we had here. Repeated multiplication I think I meshed my C and my A. Multiplication is represented using exponents. So, right, 4 times 4 times 4 is 4 multiplied by itself 3 times. Okay, got it. And what about repeated division? So, repeated division, oopsie, division, there we go, not division, is represented also using exponents. Well, like in this one, that repeated division, we could represent it as taking a half. So repeated division is represented using exponents too, but with the opposite. So with fractions or opposites, with fractions So now this is something that I want to show you. I'm going to maybe go back. Opposite. So repeated division is represented using exponent 2, but with fractions or opposite exponents. Okay, so, or negative exponents. Up here, I decided to use fractions, but I kind of ignored this division part. So you might have to look at that. We're going to do in the next example, we are totally going to look at that. And we're going to come back and fill in this remark with an example, and then maybe rewrite this even. All right, so talk to you in part 2.